In this session, let's discuss about stemming. We'll explore a powerful technique called stemming that helps computers understand and process human language more effectively. Don't worry, I'll break it down in simple terms and we'll have some fun along the way. So, actually, what is stemming? Imagine you are sorting through a library of books and you come across words like run, running, runner, and ran. They all share same basic idea but appear in different forms. Stemming is the process of reducing these words to their root form, known as the stem. This helps in grouping similar words together, which is incredibly useful in text analysis. Why do we need stemming? When we are working with text data, especially for tasks like search engines, sentiment analysis, or spam filtering, we want the computer to understand that different forms of a word are essentially the same. Stemming simplifies the text, reduces complexity, and improves the efficiency of our algorithms. So let's get started with some code. First is like we will be using Python obviously and the natural language toolkit NLTK library. This is already installed on my system, so I am not going to run this cell. So once installed, let's jump into the writing some code. We will start with importing the necessary libraries. That is this one. When it is black here, it means it's running, it's completed now. We'll start with a list of words to see how stemming works. These are my list of words: running, jumps, easily, fairly, happier, flying. You can see activation, relational. Okay. So first up is the porter stemmer. In stemming, there are different types of technologies, right? Like functions developed. First is Porter stemmer, one of the earliest and most commonly used stemming algorithms. This one. Let me run this. So words like running and here, this is the output. Words like running and jumps, okay, are stemmed to run and jump, which is great. However, words like easily become easily, see this, and flying becomes FLI, fly, which aren't real words, right? So those are pros and cons of that porter stemmer. Next, let's try the snowball stemmer, which is an improvement over the porter stemmer and supports multiple languages. See here we have chosen language English as well. Now let's analyze this output. Fairly is now stemmed to fair, which is more meaningful. Other issues remain similar to porter stemmer as well. See here flying is still FLI. The next is regexp stemmer. Let's run this. This regexp stemmer allows us to define custom rules using regular expressions. If we see here. So by customizing the rules, we have more control over the stemming process. Running, where it is here, becomes run, which might not be ideal. Flying becomes fly, which is accurate. Easily became easy, fairly fair. Happier became happy, not why but I. Okay, this is how they behave. So pros and cons of stemming. These are the pros. It simplifies text data by reducing words to their base form, reduces dimensionality in text analysis tasks, improves the performance of algorithms by treating similar words the same. Coming to the cons, can produce stems that aren't real words. We have seen in above examples, right? And may change the meaning of words due to aggressive chopping. Doesn't handle irregular word forms very well. Generally, when to use stemming. Stemming is useful in applications where the exact meaning of words isn't critical. It is not whenever it is not critical, okay? And we need to process the large amounts of text quickly. Examples include search engines. Example, matching, connect with connecting. Topic modeling, spam detection. Think of stemming like trimming the branches of a tree to get to the main trunk. For instance, if you have the words gardening, gardens, gardened, stemming would reduce all this to garden, making it easier to analyze data related to gardening activities. So limitations about and the next step is lemmatization. While stemming is helpful, it doesn't always produce actual words, right? Which can be a problem in some applications. This is where lemmatization comes into play. Lemmatization reduces words to their base or dictionary form, which is nothing but lemma, but considers the context and part of speech, leading to more accurate results. So let's wrap up. Stemming is a fundamental technique in NLP that helps in simplifying and pre-processing text data. By reducing words to their stems, we can improve the efficiency of text analysis algorithms. So, key takeaways are stemming reduces words to the root form, which we have seen with our examples. Different stemmers like Porter, Snowball, Regex have different approaches and results. Be mindful of the limitations of stemming in your projects. So try it yourself, guys. Like experiment with the different words, the above codes and stemmers, and there might be more stemmers, right? I have given some examples here, three of them. See how they handle various word forms and consider how this might affect your text processing tasks. Thanks for joining me on this exploration about topic stemming. If you enjoyed this video and found it helpful, please give it a like and subscribe for more content on NLP, machine learning, deep learning, and artificial intelligence. Feel free to leave your thoughts or questions in the YouTube comments. Happy coding and see you next time.